Hi everyone, welcome to the Agosto and Elastifile webinar. So hi, I'm Jeremy Priest, the Director of Cloud Infrastructure here at Agosto. I'm joined by Dave Payne from Elastifile.
Hello, good to be here.
Nice. Well, I wanted to start by sort of introducing the Elastifile subject and how that applies to Google Cloud Platform. And I thought I'd do that by sort of reviewing our current customers and what their challenges are around cloud projects. We often find that customers really feel that they need to fix all of their problems that they have during their cloud migration project. And that's a good goal and a goal that customers should have over a period of time. But if we put it all into one single project, it does get to become too much change at once, and the project can go through an analysis paralysis type of phase, and eventually extend on for too long to be seen as a successful project. Another spot our customers are challenged is in the data migration side, and how do we move this bulk of data in a timely fashion with a minimal disruption to our business in order to cut over to the cloud. And then finally, one of the key challenge categories is on compatibility. And is my application, is my operating system, is my infrastructure compatible with whatever public cloud provider that I choose? Last summer, Agosto ran a survey of our existing customers, and we asked them a bunch of questions. Among them is, do you feel app replatforming is necessary as a part of public cloud migration? And we see here that a large chunk of our customers were unsure. Some of them feel that yes, you need to replatform, and a minimal amount thought that replatforming was not necessary. And we really it's interesting that the customers found that they were unsure, as well as some found that they need to replatform, when I don't know that that's necessarily true if you approach the project properly. So we view apps fall into two buckets. One is a born-in-cloud app. We spend a lot of time in our industry talking about these new apps that are being written, minimal infrastructure assumptions. Basically, the resiliency for the app is built in at the app level, when the born on-prem apps that we have, decades of history with have relied on the infrastructure for durability. So you can see that falls into a couple of categories. Storage, network security are some examples. And we're really here today to talk about the storage aspect, and in particular, file-based storage. And in that place, we have our key partner, and that's Elastifile. And I'll let Dave pick up from here.
Cool, thanks, Jeremy. Appreciate the introduction. So yeah, we kind of live right in the middle of this opportunity where you see, people trying to get into cloud, and with sort of a fever pitch. The pace is picking up. I think the benefits of on-demand, limitless infrastructure, pay as I go, worry about my application more and less about infrastructure is really appealing. But what we're finding is there's a pretty big gap between the born in cloud applications and these ones born on premises. So we've partnered up both with Google and with and Agosto to sort of address some of these needs as it relates to storage. And it turns out that whether you love storage or hate storage or have a relationship with both, you really can't get away from it, whether it's on-prem or in cloud, because that's the data is really one of the stickiest parts of any application. So we'll kind of break down some of this problem a bit over the next few minutes, show you an example of how we're addressing the issue, and trying to bring the born on-prem applications to a cloud-native infrastructure without too much pain, really, so we can get to cloud as fast as possible, and realize the opportunities both in cost savings and business agility that digital transformation offers today. Okay. So netting out, really what we've done here is, as Elastifile, we've created a software-based storage platform that's designed to be compatible with traditional POSIX applications, yet scale like cloud infrastructure. So from the end user perspective, they see a simple storage interface and like an NFS mount, for example. But on the back end, it can scale elastically and horizontally like cloud infrastructure would. So really trying to solve the gap between the two. So let me take you through a little bit about how we do that. The idea with cloud storage in this case is when we're trying to really broaden the reach of applications that can sort of plug and play into cloud. And we believe that having an in-cloud file system that's compatible with all these applications is key to making that happen. There's a lot of ways to approach this. Certainly, there's not one single way to stand up a file system in cloud. In fact, all of the cloud providers have massive storage capabilities, but the devil's really in the details. As Jeremy was saying earlier on, often what happens is when people want to go all in cloud, a lot of times that energy is tempered by running into some of these roadblocks that storage presents, and you quickly figure out what the details are. For example, I want to take a Oracle application and run it in Google Cloud. How do I do that? You run into a myriad of issues between licensing and storage compatibility and server compatibility, and pretty quickly you've stumbled into kind of a quagmire of issues, and you're really not making progress. So really, from an in-cloud file system perspective, in order to make it work, it needs to be sort of holistic. And I'll show you 4 areas we'll focus on over the next few minutes in the presentation. So first is it's got to be easy to use. Kind of the promise of cloud is I don't have to really spend a lot of time messing around with infrastructure and turning digital wrenches and the like. I need to be able to spin things up, use them now, and really move to the next issue. Secondarily, it has to be performant, right? I mean, it's the cloud kind of offers this idea that I can start small and grow big, and performance will scale along with my needs. Both performance and capacity need to kind of align with that. Thirdly, scale. When I roll out machine number 1, I should expect X level of performance. And when I roll out machine number 1,000, 10,000, 100,000, I need to be able to expect that I can have the same deterministic performance and ease of use as I hit these scaling metrics, right? And then lastly, all that's great, but unless I can meet a cost model that aligns with my business needs, it's all sort of a non-starter, right? And this is where we translate from technical doability into the commercial side of the equation. That really tends to be one of the big drivers behind a move to cloud. Okay, so let me walk you through a little bit of what that means and kind of Elastifile's approach. So when we talk about an in-cloud file system, let me bring it down to a little more practical level. Really what we're talking about that we bring to the table is POSIX compliant storage. And if that's a word that you're not familiar with, what it really means is POSIX is essentially the protocol that traditional Linux type and Windows applications are built on. If you talk about things like NFS or SMB storage or block storage and the like, typically if it's a traditional file system, it's probably POSIX compliant, which also means that my data is stored in a consistent way. Often big scalable object storage is loose, or it's eventually consistent, meaning when I write data, it eventually gets replicated to many places, but I can't guarantee that the next read will be the last piece of data written. And so when you run applications like databases or any sort of transactional workloads that need surety that when the data is written, the next read is the last one written, that's where POSIX compliance is required. So if you have applications that require, NFS mounts or SMB mounts and things like that, they're, mounting exported shares or, shared file systems and the like. That's traditionally what POSIX compliant storage tends to look like from a presentation perspective. Applications that need distributed parallel file systems, so large scale where I can have tens, hundreds, thousands, tens of thousands of concurrent connections to the back end, still while needing POSIX and NFS mounts and the like. That's really what we designed for. Another thing about our in-cloud file system, we've designed it to be with enterprise in mind. So features like snapshots built in, the ability to asynchronously replicate data site to site, data reduction features to take costs down, like compression and deduplication, high availability features, ability to back up data to object storage natively. Things like this are built into the file system, which typically don't come unless you have enterprise class storage. Okay. Lastly, this is, we designed this technology to be available to spin up on demand in cloud today. Elastifile is a software-based product, so it runs on commodity hardware and commodity cloud providers. So we can spin it up just as easily in Google Cloud as we could on local servers and storage in an on-premises data center. Okay, so that's kind of the in-cloud file part. What does that mean to you? So if you have applications that require a file system, first of all, this is probably right up your alley. Any database applications across the gambit of traditional SQL databases. If you want to run those in cloud, typically you're going to need either block storage or a scalable file system. Stateful containers is a big topic. A lot of people are moving applications into Kubernetes and Docker and container infrastructures. And what we're finding is traditional apps like running a MySQL database or Postgres database, in order to run that like I do on-prem, I need to maintain state. And we find if we have a shared file system that can plug straight into that, we can solve a lot of the issues that exist between a stateless container and a stateful data experience. VMs tend to be good candidates for this as well if I want to run traditional VMs in cloud. And then you move into, with an in-cloud file system, we can start consuming research type applications. And this is a real broad category that we're finding. Everything from research applications from universities that are doing research across the board, from life sciences, finance, oil and gas, to more industry-specific applications like media and entertainment. People are trying to do rendering projects in cloud and the like. A lot of these research applications tend to have lots of files and lots of file needs, and a lot of applications that are very mature and not ready to go right into cloud. So we can often solve a lot of the data needs there with this. And then if, in general, if you're thinking, what else do I have that's it's hard to get in cloud? A lot of times you look at what applications are running right off your NAS. And we provide a means to essentially lift those up and drop them right in cloud. Okay, so that's kind of the basis for what an in-cloud file system is and what it's used for. Let me show you a little bit about how we approach it from an infrastructure perspective. So essentially, Elastifile is a scale-out file system. It's a shared nothing architecture where you can write anywhere into the file system. And what all that means is, instead of having one big storage array, which literally can't go into cloud, what we do is we roll out our software on Google Compute Engine nodes and distribute a file system across them. So you start out with at least 3 nodes that we aggregate the storage from them together. We present a file system up to applications, and essentially anything that could reach us via IP and do an NFS or SMB mount could access the file system from there. As needs grow and I need more capacity or performance, I just add nodes into the infrastructure. Click of a button or an API call away and the system grows. And then if I don't need the capacity anymore, I can shrink it back down, or I can just delete it. It's really easy, since it's in cloud, to instantiate a new file system, grow it, or take it all away, which is consistent with cloud usage. A lot of times people are looking for temporary surges or bursting of resources in cloud. And this is consistent with that. So I can kind of have the best of both worlds, traditional interfaces, NFS, but I can get cloud-like elasticity behind the scenes. Okay, so that's kind of the primary file system that we offer. We also have a capability to extend the primary storage from kind of this high-performance tier that runs in Google Cloud Engine into object storage. And so we have a feature that's called Cloud Connect that effectively will extend a file system construct into cloud storage. It can check data in and out from cloud storage. So think of it as we're taking versions of a file system, any portion of the namespace, and we can take space-efficient copies of those and store them in cloud. So this is great for backup purposes, archive purposes, or it's essentially trying to extend my namespace into a larger bucket while being sensitive to cost. The cost per gigabyte in a primary active high-performance file system will be larger than cloud storage. All right, so we kind of put our performance stuff over here and kind of cheap and deep storage on the right side. Okay, so together that forms a file system and kind of solves for performance needs and cost needs. And then the other angle on this is, we're talking a lot about enterprise applications that are living on-prem today. And so the idea here is we can connect these systems together and facilitate this idea of lifting applications from the on-prem side, shifting them into cloud, whether that's a one-time permanent move, or it's something that may want to go back and forth, the proverbial, surging and bursting use cases. So at Elastifile, what we can do is we can either roll out an Elastifile file system on-prem and in cloud and connect them together with Cloud Connect. So allow you to choose where you run your applications, or Cloud Connect can actually reach in to any local file system, grab the data, take versions of it, move it into cloud, and when you're ready, roll the application side of that into cloud as well. Okay. So moving on. So the next piece of that beyond or into the in-cloud file system is an ease of use story. And the basic idea from our perspective, and I'm presuming that a lot of the audience here we're speaking to is people that are more on the kind of architecture and administrative side of IT. We want to meet you where you are. So we designed, user interfaces that either are sort of point and click GUI based, where you can manage the system easily. I have a screenshot of a console. We're looking at, traditional infrastructure views, how much capacity I have, what's my performance look like, and other features like that. Or if you're more in the automation side where, you want to manage through an API, we have a full API that we expose, or command line interfaces for more scripting and kind of ad hoc work done like that. So this allows us to, to meet people where they are from an administrator's perspective, and also take advantage of some of the more modern approaches to infrastructure automation, commonly referred to as infrastructure as code. So we're finding a lot of our customers are using these command line and API interfaces to automate through Terraform and Ansible and Puppet and tools of that sort. Okay. The other thing is it doesn't have to be hard, right? I talked about simplicity before. We can stand up a brand new cluster from scratch with automation in under 3 minutes, scale that to whatever size that we need elastically. So we can stand up and get to work quickly and then go away when the work is done, right? And so the cloud becomes much more dynamic than we're used to with traditional sort of rigid infrastructure that we run on-prem. The ability to check data in and out of cloud storage is really helpful for people. So again, they can make decisions about where their data needs to live, on-prem, in cloud storage, or in an active file system. And then again, meeting where you are from the customer point of view, your customers or your clients, let's present interfaces like NFS and SMB that they're used to, their applications are already compatible with, and they just work, okay? So let's talk about performance a little bit. I'll give you an idea of what we mean when we talk about performance and where we tend to fit. If you think about the nature of the applications you're running from a storage perspective, we designed a file system, and this is where we differentiate from other file systems that are traditionally you're used to with NAS products and the like. Is we designed one that's really optimized for applications that require a lot of I/O. And low latency. So it's one of the reasons why I started talking about databases and the like, is this is, kind of straight up the middle applications they consume a lot of IOPS. They require really low latency, like sub-millisecond response times in order to function well. And achieving that sort of performance profile in cloud at scale has been traditionally pretty tough, actually. And so we designed for that to be able to consume on demand thousands or millions of IOs at a consistent low latency level. And then, moving from that, handling these transactional workloads, we designed for small blocks, lots of small files, these areas where, traditional NAS has really suffered. So we don't really view ourselves as a NAS product. We're more of a storage product, but we use NAS-like interfaces. But here's where we can handle, workloads that would traditionally only work on big block storage arrays and the like. So on top of that, we look at throughput workloads as well. There's options for doing throughput in different ways, but here we can handle really high throughputs as well in a scalable way. We really optimized starting with small blocks and moving up to kind of larger block sizes. And I'll show you an example of how we scale with that on the next slide here. Okay, so then basic idea on this is present a wide performance band, consume a majority of the applications that probably run on-prem today, and provide interfaces that make them easy to run in cloud. All right. So here's an example of some testing that we've done, comparing an open source file system that people are commonly spinning up in cloud. And we use this as an example to kind of show a baseline versus someone else's approach and us. So what you're seeing here is several examples of different read-write patterns of storage I/O. The first one on the bottom left, we're looking at a full read workload. And the basic idea here is what you see as these 3 data points. As I increase the demand on the system, I get this nice linear scale where performance goes up and to the right. And so there's a full read workload. Here's a heavy write workload. Again, same idea. Performance is going up and to the right. And then when I get into mixed workload scenarios, it's consistently the same. So this is small block here. So this is more like your database type workload, or maybe a research project that has millions of small files that are pounding the system and updating that data quite frequently. Then I get into larger block workloads, where maybe this is more streaming type, media and entertainment type examples, or just ingesting really large files in the multiple megabyte or gigabyte sizes. So same story, right? Up and to the right performance, and what you'll see in some other examples will show that as we consume these sort of workloads, the latency stays nice and low. Okay. Third point is about scale, right? Can I maintain that same level of performance at scale? I'll show you some examples of that. A couple of the ways that we've approached this is we created a distributed parallel file system, which means you can write anywhere into the infrastructure. So as we add more nodes, our capacity to deliver performance increases linearly, right? We can kind of out of scope for this whole webinar and the time that we have, but there's a lot of really cool tech behind the scenes that we've come up with to solve for traditional metadata scaling problems that you find in file systems. Okay, we distribute metadata management horizontally, just like we do everything else, and so we eliminate the bottlenecks that typically come from that. So ultimately, on point number 2, we're trying to provide a deterministic performance profile. All right, so there's no surprises later on when I hit a certain capacity or performance level. I can just keep on growing. Okay. So I'm going to show you an example here of the test that we ran, and this is kind of bridges right in the middle of the born in cloud and born on-prem applications. And so what we did here in Google Cloud is we rolled out a 30-node Elastifile cluster and a big 1,000-node Kubernetes container platform. And so we spun up a bunch of these containers. You're seeing OpenShift here in the UI. And so what we have is eventually you'll see these 1,000 containers running. We spun up an application that generates a really heavy file system workload. There you go. Here's all the containers running. And we made 10,000 concurrent connections from these containers into the backend storage. Okay, so to start out, we spun up 250 containers, 10 connections each. There's about 2,500 connections going there, and so we'll kind of baseline. You'll watch these numbers as they grow. So you double the amount, about 500 containers, and I'll pause it here and kind of take you through. So what you're seeing is throughput just doubled from about 750 megabytes per second to 1.5 gigabytes per second. I/O just doubled from about 150 or 160 to 270,000 I/Os per second. And then latency staying nice and low, right? We're aiming to keep this under 2 milliseconds at extreme load, and almost always under 1 millisecond, okay? So we'll watch this play out at another 250 machines and another 2,500 connections. And we'll see this start to scale. Again, nice and linear. Performance is 2.3 gigabytes per second. We're at 500,000 I/Os now. And you start to get the picture, right? We're pushing 3 gigabytes per second, and we'll just keep meeting demand as it comes. So that's really kind of what it looks like, is the ability to take an application, and these could be MySQL databases inside of a bunch of containers. They're achieving persistence and performance and scale, really all on demand. Okay. So let me pop out of that. There we go. Oh. So lastly is cost, and dealing with the cost issue is really important. And this is an area where, I got a couple bullets here, but it's one where we spent a lot of time with our partner Agosto to really figure this out. There's no one answer to how you deal with cost in cloud. A few things that we found is, the idea of using hot and cold architectures, meaning, keep my hot data in active high performance architectures like our file system, and our cold data in more cost-effective storage like GCS, is a way that I can more easily manage my cost as opposed to more fixed architectures on-prem. The idea of bringing simplicity into the equation to reduce costs. If I don't have to manage it, then I don't have to put people against it, and I can take those human resources and put them against more urgent and more pressing problems to the business. The ability to create a lot of automation in there just eliminates a tremendous amount of work that's traditionally done on-prem. So what we found is, in cloud, ultimately, I only have to pay for what I actually use. And so, since I'm not, buying fixed infrastructure for a single application, I only pay for, what I'm using when it's using. You find the net of it is there's huge opportunities for cost reductions. And we've seen that with customers. I have an example on point number 3 here where, some applications that had dedicated infrastructure, since you're eliminating the dedication and spinning things up on demand, you're literally just taking, massive amounts of cost out of the equation. So again, there's no specific rule of thumb for how to do the cost equation, but we find that this is an area where our friends over here at Agosto spend a lot of time and energy to figure that out, taking in both capital expenses and operating expenses into account. Okay, so kind of wrapping it up on the Elastifile side of this in a nutshell, we think we're really going after one of the biggest hurdles to getting applications into cloud, especially the born on-prem applications. The ability to bring an in-cloud file system that's scale out, performant, easy to use, and able to adjust itself to the cost dynamics of play is really a way to kind of accelerate the cloud adoption story. Okay, so Jeremy, how about I hand it back to you?
Yeah, awesome. Thanks, Dave. Good job. So the next question might be, where do I start? Right. We first of all, our cloud adoption methodology meets our customers with wherever they are. Some people would call that their cloud journey, whatever you want to call it, right? Whether you're entirely on-prem today or whether you've adopted one of the many cloud options or maybe a managed service offering, we would meet you wherever you are. I wanted to lay out the one slide here that's the slide we show to people that haven't started. If you're entirely on-prem, what do I do next? I'm not quite sure what to do. There's a lot of analysis that could be done before we move, and how do we approach that in order to make some progress within our organization. So we offer a cloud assessment that is a spot for customers who want to dive into what are my requirements, what are my costs associated with that, and how does my compatibility look? Are there any red flags here? Do my apps work in the cloud? That sort of thing. As we move to the right, the enterprise workshop facilitates the meaningful experiment. And we believe everybody, if they haven't gone through it yet, needs to go through a meaningful experiment. That would be if you're already on AWS and you want to have a multi-cloud strategy and adopt GCP, or whether you're on-prem going into GCP. Either way, it's really important to go through a meaningful experiment process. And that for us is something that's real, something that's small and easy to move, and something that's not the most critical if you have some hiccups. And what your organization gets out of that is really some practice. Understanding what are the operational challenges with moving here? What do I do in terms of disaster recovery? How do I communicate with it in terms of networking and integration with our other, various infrastructure components and operations? So the workshop facilitates the meaningful experiment. At the end of all that, when you get to the far right, you're able to validate, were we successful? Did the financial model end up working out? And at that point, you would go through and sort of dive into a more comprehensive cloud adoption strategy. You'd be ready. And we have services for that. I wanted to start here, though, by just talking about, where do I start? What do I need to do to get going? And the answer to that is really give us at Agosto a call, and we can sit down with you and understand, what are you running? What motivates you? Why are you interested in cloud, and how can we help you? And from there, we can really bring in Elastifile when we need to, bring in other third-party partners that we have when we need to solve gaps, and go from there. I think we can wrap up here. Thank you everyone for attending. Thanks, Dave. Really appreciate your time here.
Yeah, it's good to join you today, Jeremy.
Awesome. All right. Thanks everybody.